Okay, so the first exercise, it says determine whether JKL or RST is similar to triangle ABC. So the original triangle ABC is right here. We're seeing if this is similar to this, and then seeing if it's similar to this over here. So first thing I'm going to do is like just identify corresponding parts, AB to JK, and then this would correspond as well. And then this corresponds to this to this here. Okay, so first step, I'm going to set up like ratios and proportions, just one shape to the other. So pink to pink, 7/6, and orange to orange, 8/7, and 12/11. If these ratios are all equal, then the shapes are similar based on side, side, side. So to determine if the ratios are equal, I'm just going to plug the numbers in the calculator and see if I get the same decimal each time. So 7 divided by 6 would be like 1.2. And 8 divided by 7, oh, it's giving me something else, 1.14. So already those aren't equal. And I get 1.09. So all of these ratios are different, so therefore these two triangles are not similar because they're not proportional. Okay, so now I need to compare the first triangle to this one over here and see if these two triangles are similar. So same process, I'm just going to put one like corresponding parts over each other. Orange to orange, 8/4 and 12/6. So I'm going to see if these ratios are equal. 7 divided by 3.5 is 2. 8 divided by 4 is 2, and 12 divided by 6 is 2. So yeah, same ratio. These are similar because of side similarity theorem. And we can say that triangle ABC is similar to triangle RST. Okay, are you ready? The next one, same idea. We're gonna compare this to this one here. This one's a little different because notice how it's not in the same orientation. So when we label the corresponding parts, we have to be careful, and we can use the similarity statement. So AB, the first two letters, would correspond to JK. AB corresponds to JK, which happens to be over here. And then BC, the last two letters, corresponds with KL. And then first and last AC corresponds with JL. Okay, then from here, I'm going to set up like corresponding parts. So use the color 16/20, pink to pink. Is that equal blue to blue? And then orange to orange, 20/25. And then to determine if these ratios are equal, I just plug it into a calculator. I got 0.8, 14 divided by 17.5, 0.8, 20 divided by 25, 0.8. It came out to 0.8 every single time. So therefore, these ratios are the same, they're proportional. So yes, they're similar because of side, side, side. And triangle ABC is similar to triangle, make sure it's in the same, JKL. And then these two are not similar, but I feel like we just need to move on at this point. Okay, then number 3 here, now we're going to solve for the value of x. It's telling us that these two triangles are similar, and we need to use that similarity to find x. So first things first, I'm going to identify corresponding parts. Sometimes you can identify it visually, like it's really clear, like this is clearly the longest side on both of them, and those would be corresponding, and then this would correspond to this. Okay, so find the value of x that makes these similar. We're going to just set up a proportion blue to blue, 5/10 equals, and I'll do orange to orange. Notice there's another set of corresponding sides, but you only have to use 2 of them to set up the proportion. So from here, just cross multiplication. Five times 14 is 70. And distribute. I'm just solving at this point. X equals 80. Divide by 20. And x equals 4. Okay, the next one over here, we're going to do number 5. This little arrow means that it's a good example to go over. So it says, determine whether the two triangles are similar. If they are similar, write a similarity statement and find the scale factor. Specifically from triangle B to triangle A. It's kind of backwards. So it's going from B to A. B is the original, and A is the new. So what I see here is side angle side, side angle side. So I'm probably going to look for side angle side similarity. So we have a 90-degree angle here, which is the included, and then side angle side, side angle side. So when I choose like corresponding, the longest side of this would go with the longest side over here, and then shortest with the shortest. And then I can set up the ratio. So I'm going to do orange to orange, and again, new over original, 8/6 and 12/9. So for scale factor, just to review, K equals new over original. Okay, so looking at this, I'm trying to decide if this is similar. So 8 divided by 6 is 1.3 repeating, and 12 divided by 9, also 1.3 repeating. Okay, so it's proportional, so yes, similar because of side angle side. So we can say that triangle FDE is similar to triangle, have to go the same order, YWX. And then it wants to know scale factor, which is new over the original. And we already put new over the original here. So scale factor is 1.3 repeating, or as a fraction, if you take 8/6 or either one of these fractions and just simplify it, you get 4/3 or 4/3, same thing. So triangle A is 4/3 times larger than B. Okay, and then on the back, we're going to go over just 2 problems and we're done. Oh, still writing. Okay, so these are both like common styles for this, so I want to definitely go over them. It says show that the triangles are similar and write a similarity statement. Explain your reasoning. So the whole like triangle and a triangle thing, very common, just to kind of take it up a level. There's 2 triangles here, one smaller one on the inside and then one larger one on the outside. Best way to do this is to just like draw them separate. So here's the smaller one, H, G, J. And then the larger one, the all-encompassing one, would be H, F, K. And now you can like label them without it being too confusing. So HJ is 16.5, HG is 15, and GJ is 18 based on what's there. And then for the larger one, H to F would be 15 plus 5, which would be 20. FK is labeled 24, and HK down here 16.5 plus 5.5 is 22. And then identify like corresponding parts just to keep yourself straight. And we're going to prove that these are similar based on side, based on what they gave us. So you just like do corresponding part to corresponding. Is that equal to 18 over 24? Is that equal to 16.5 over 22? And then you just divide it. I got 0.75. 18 divided by 24. 0.75 again. 16.5 divided by 22. 0.75. Okay, so it comes out to the same decimal every time. Yes, similar because of side similarity. So triangle HGJ is similar to triangle HFK. Okay, number 10, relatively straightforward question. It shows two sides and then vertical angles are equal. So here we're going to try to prove side angle side similarity, like side angle side, side angle side. The only tricky part is when you have this situation, a lot of times what corresponds is kind of like opposite. So looking at this, we have a 21 and 27, like 21's the shorter side, and over here 14 and 18, that's the shorter side, 14's the shorter side. So just put like short with short and those correspond. And then here, like the longer one with the longer one and those correspond. And so setting this up, I'll do 27 over 18. Is that equal to 21 over 14? And if it is, then we have side angle side. 27 divided by 18 is 1.5. 21 divided by 14 is 1.5. So therefore, we have side angle side similar. Yes, similar, side angle side, triangle ACB is similar to triangle DCE. And we're done. Okay, so your to-do list is homework 8-3 on Schoology. And then work on Alex if you have time. Also ask questions, please. Yeah, go ahead and get started.